In my opinion, one of the most amazing discoveries of the 20th century had to do with dark matter. Now, to give you a little bit of a sense of what dark matter is, there's regular matter, or bosonic matter, like us, and this is matter that's copper and hydrogen and helium and all this. This is what makes up stars and the earth and you and me and our cell phones and everything else. And this matter interacts with light, but it's a different kind of matter, and we call it dark matter, and it doesn't interact with light. It mainly interacts through gravity. You see, there's been this problem, and it's been known for some time, even as far back as the 19th century. See, a man named Lord Kelvin, and if you're curious, it's the same Lord Kelvin that has the unit Kelvin named after him, this absolute value of temperature. He sat down and he measured the rate at which stars orbit the center of a galaxy. You see, stars orbit around a galaxy, much in the same way that planets orbit around a star. And you can calculate the speed that you would expect these objects to be orbiting that central point. Now, for planets in a solar system or in a situation like that, you expect that speed to go down. So in other words, the planets that are further away from the sun, they move more slowly than planets that are closer to the sun. We expect the same to be true in the galaxies. The distribution of that speed, how that speed falls off, is going to depend on the distribution of stars in the galaxy, but we expect that number to fall off. Now, back in the 1970s, nearly 100 years after Lord Kelvin had made his measurements, a woman named Vera Rubin and a man named Kent Ford measured the speed of the interstellar gas. You see, there's gas that's between stars and galaxies, so it's not completely void. Not a lot of it, but in fact we can see it. We can see it using other kinds of radio, X-ray, and infrared techniques. And they measured the speed of this gas orbiting the galaxies, and they found the same thing Lord Kelvin did, which was that the speed of the gas at the edge of the galaxy was just far too fast. Not only that, but they couldn't measure enough of it to account for the difference in the speed of the objects at the edge of the galaxies compared to the inside. And so they said that there's this missing amount of mass, this mass that they can't see, and it's about maybe 6 times more than the amount of the mass that they can see. And they called that dark matter. And we've seen this over and over and over again, the presence of dark matter. Sometimes this dark matter comes in the forms of what we see in terms of the rotational speeds of objects, but also it can come into the way that galaxies and clusters of galaxies move and clump together, or what's attracting them, or how quickly they're moving. When we try and calculate exactly how much mass there is and how much mass there should be, there's a discrepancy, and it's large, it's enormous. We're seeing from gravitational effects far more matter than what we're able to actually view. And so we come to this notion of dark matter. Now it might seem like maybe we have it wrong. Maybe dark matter really doesn't exist and we don't understand what's going on, but that also isn't true. Relativity has something called gravitational lenses. Matter in space-time bends and warps space. The Earth does it, the Sun does it, everything does it, and has mass in this universe. And there's distortions, sometimes of enough mass, these distortions can cause things like what we call gravitational lenses, and they distort space and time and shape it much like a lens. And so instead of just when you look out, it's almost as though you looked out into a starry field, but you put this lens in front of your eye between them. So it looks distorted and weird. Sometimes you'll get a star that'll appear twice in the sky, and other things like that. These very strange, anomalous viewing, these very strange and anomalous patterns in the sky, and we've seen that. And in fact, we've been able to observe the presence of dark matter through the distortions of space-time that they've actually made. You know what the crazy thing is? Now, the universe is made up of a lot of stuff, and most of it actually isn't even matter. But of the matter that makes up the universe, 80% of it is dark matter. 20% is matter like us. That means that most of the universe is made up of stuff that we barely know anything about. We can't attribute it to any subatomic particle. All we know really is that it interacts with gravity, and that's it. And it could be surrounding us right now, and we would never even know it. It's not neutrinos, it's nothing that we know of, and we've tried and tried and tried to figure out what this stuff is, and we just can't figure it out. It's one of those great mysteries that kind of plague us today. Well, I hope you enjoyed this video. If you like what you see, please like and subscribe to my channel. And everybody, have a wonderful day. Thank you. Bye-bye. This has been a video from Van Cleef Scientific. If you like this, please like and subscribe for more content.